Today we're working on Algebra 2. This is section 6.6, example 5 and 6. So using inequalities. So just like we learned the other day, when we have a function and it has x in the exponent, this is an exponential equation, or in this case, because it has a less than symbol, we call it an exponential inequality. And so what happens is to solve this to the inverse of an exponential equation is to take a log. And since this is 3 to the x, we need to do log base 3 on both sides. We're going to do log base 3 of the left side. It stays less than, nothing changed. Log base 3 of the right side. So on the left side, this log base 3 of 3 to the x turns into x is less than. And then if I go ahead and do log base 3 of 20 in my calculator, how I'm going to type it in is I'm going to use change of base, and I'm going to do log of 20 divided by log of 3, and I get 2.727. So my answer is x is less than 2.727. Now, we're also going to learn about when we need to watch out for negatives. We don't need to worry about anything when it's exponential. We only have to worry about it when the initial problem is a log. So let's actually go ahead and we'll come back to example 6. Let's do this practice right here. So how we get rid of a base of e is doing a log base e, which remember is the same as the natural log. Okay, so I can take log base e of both sides, the left and the right, or remember that log base e is the same as natural log. That's just an easy way to type it in our calculator. So you type in natural log of 2 and you get 0.693. And that is your answer. Remember that we're going to learn about when we have to pay attention to kind of some funky logs cannot be 0 or negative type things. But since this was exponential to start with, we don't have to worry about anything. Okay. So let's look at this one. I just kind of like to do the similar ones real quick. Since this is a 10, you're going to do log base 10 of the left side. Oops, sorry, I wrote that wrong. The left side is log base 10 of 10 to the 2x minus 6. There we go. And log base 10 of 3. Okay, so the log base 10 of 10 to the 2x minus 6 leaves us with 2x minus 6. And then log base 10 of 3, I can just type in my calculator log 3, because remember log 3 and log base 10 are common logs, so they're the same thing. So we can just type that in our calculator. And then we're going to go ahead and we're going to add the 6 and divide by the 2. 6.477, and then divide by 2. And you can do all of that in your calculator. 3.239. X is greater than 3.239, and that's our solution. Okay, let's go back up to example 6, and let's do this with logs now. So here's the log. So remember that when it's a log, the inverse of a log is an exponential. So keep in mind, this is log base 10. So we're going to take the left side and raise the left side to the power of 10, and raise the right side to the power of 10. All right, so 10 to the second power. Okay, so when it's a log, the opposite of a log is creating an exponential. So on the left side, 10 to the log base 10 of x just leaves us with x. On the right side, 10 squared is 100. Now, when it is a log, all right, remember the rule we learned about logs is log functions, can't be 0 or negative. So since logs cannot be 0 or negative, although x is less than or equal to 100, it also has to be greater than 0. Not greater than or equal to, because it can't be 0, just greater than 0, because this log of x, can't be 0 or negative. And so that's why we have to include that, oh hey, x has to be greater than 0, which is the same as 0 is less than x. And so we include that because can't be 0 or a negative number. Okay, let's look at another one with that. Let's go look at the practice over here. So on this one, I'm not going to take it and raise it to a power yet because this plus 9 is not inside this log. If it was in parentheses like this, then yes, I'd be ready to raise it to a power, but it's not. So the 9 is not part of the log. So before you do anything, move the 9 over. So you get log of x is less than, and then 45 minus 9 is just 36. Okay, remember this log is the same as log base 10. So you're going to raise the left side, be 10 to the power of log base 10x, and the right side is 10 to the 36. Now, honestly, that 10 to the 36 is really going to overwhelm your calculator. Think of that, that's like 10 with 36 more zeros. And so we're just going to leave it as 10 to the 36. We're not going to write it out with 36 zeros. It's kind of wild. So because this was a log, remember what would make this log 0 or negative is with x is cannot be 0 and it can't be negative. So we put that x must be greater than 0. We tack that on. And because it was a log is why we have to pay attention to this. Had it started out as an exponential function, we wouldn't have to do that. Okay, let's do this one. So we have to get this natural log by itself before we can try to solve it. So first rearrange, get that 1 out of there. So 2 times the natural log of x is greater than 5. All right, and then go ahead and divide by the 2 because we want to get natural log all by itself. So natural log of x is greater than 2.5. Okay, remember that natural log is the same as log base e. All right, so that helps you to know, okay, on the left side, I need to raise it to the power of e because natural log is log base e. And on the right side, raise it to the power of e. All right, so I'm running out of a little bit of room here, but we're going to go ahead and just keep going. I have x is greater than, and then I'm just going to type in my calculator e to the 2.5. And so let's see here, I get 12.182. And I don't have to add anything over here. And the reason why is, think about this. This means all your x's are greater than 12.182. Well, there's not a possibility for them to be 0 or negative if we know they are larger than 12.182. And so that's why we don't have to add the x has to be greater than 0 because it's already greater than 0 if it's greater than 12. And that's why we just leave that one where it's at.